I expect more people to join, like previous webinars. So we get off to official start of the program. Good afternoon and welcome to all participants and our speaker of the day, Shri.Jameskutty Thomas. This is the third day of Electrical Safety Webinar Talk being held by HSC Forum of National Safety Council Kerala chapter together with the Electrical Inspectorate. It is my honor to facilitate today's safety webinar. I am Nanda Kumar, convener of HSC Forum and Senior Associate Vice President from Carborundum Universal Limited. Our first webinar talk in connection with the Electrical Safety Week 2023 was held on 26 June 2023 on the topic of electrical safety in industries. This was followed up by the second safety webinar talk on 27th June on the topic of enhancing electrical safety in industries through safety audit. Yesterday, we had a talk on electrical safety in buildings by Shri Krishna Kumar, Project Associates, International Copper Association India, and CEO of SEAM. It's quite gratifying to note that good patronage from participants for all the past three webinar talks. We had more than 40 plus people joining from various parts of our state for hearing the experts talk on electrical safety. Today also, so far we have 22 participants and I hope we will have more people joining in and expecting again 40 plus or more participating in this webinar. Today, we bring to you a topic of significant interest to all the people ensuring electrical safety at home. The speaker is quite well known to all of us, but for sake of formality, allow me to introduce Mr. Jameskutty Thomas, the speaker of the day. Mr. Jameskutty is BTech and MTech by qualification, and he served as electrical inspector in the Department of Electrical Inspectorate, Government of Kerala, till his retirement 2 years back. He has over 29 years of experience serving Department of Electrical Inspectorate, Government of Kerala. He is also a chartered engineer and member of Institution of Engineers India. He is very active in various fields like auditing, valuation, inspection, training, and also provides consultancy services for HT and EST power systems, solar PV installations, and lighting protections. In fact, he is an authority in almost all areas of electrical engineering, I would say, and also equally good in electronics part also. Good as good speaker, and for National Safety Council, this is not the first time that he is appearing as a speaker. This is, I think, more than third time or fourth time he is coming as a speaker for the National Safety Council Kerala chapter. On behalf of HSC Forum, I extend a very warm welcome to Shri.Jameskutty Thomas for his talk today. I also welcome all participants to this session. I request all participants to keep their audio on mute. Any questions that you have can be posted in the chat box. We will take the questions for answering after the talk is completed. So once again, wishing a warm welcome to all participants and requesting our speaker, Mr. Jameskutty, for delivering the technical talk. Over to you, sir.
Okay, thank you. I think I can start or wait for a few minutes.
Yes. Yes, sir. You can start.
Okay. Thank you. Good afternoon, everybody. As Mr. Nandakumar introduced, you know me as Jameskutty Thomas, retired from electrical inspector. I don't know how many of you know about the Department of Electrical Inspectorate. Based upon the subject electrical safety, I would say electrical inspector or chief electrical inspector is the authority of electrical safety in our state. So if the as per the standards, we should inspect or we should conduct the inquiry within 24 hours, and we should collect all the evidences from the site, and if it is fatal, we should inquire how the accident was happened. Like that, the process is going on, and finally we will prepare the whole report after collecting the statements from the victims and all those. And we will be submitting the report to government. So here today the topic given to me is electrical safety at homes. To practice electrical safety either in an industry or anywhere, it is better to start study from our home premises itself. Today, in our day-to-day life, we know we have changed a lot. From the conventional household appliances, now we can't live without electrical appliances such as induction cooker, fridge, mixie, grinder, mobile, or iron box, or etc. etc. Now, electricity. What is actually electricity? Electricity is as dangerous as it is useful. These are the basic definitions. Unlike other products we use every day, we can't see, hear, or smell electricity. So we may not always think about using it safely. A moment of carelessness or a piece of faulty equipment can cause an electrical accident. Minor electrical shocks could be fatal, and minor errors while handling electrical equipment could hurt you. The more we learn about the safe use of electricity, the less our chance of injury. Electricity gives us light, but do not take electricity lightly. Actually, the unseen electricity must be handled very carefully. Otherwise, we may face fatalities and injuries. So handle them very carefully, for which we must understand the safety points based upon which electricity need to be handled. Let us see the record from National Crime Records Bureau of India. As per this record, about more than 30 fatal accidents, electrical accidents are occurring in India per day. See, it is a large number, you know. Now let us see the status in our state. What is the status in our state? See here, about 210 human died from 1/4/22 to 31/3/23. It is really very pathetic. But comparatively, the rate of electrical accidents are getting reduced due to the statewide effective safety awareness that we are giving, and due to effective implementation of electrical safety guidelines. And now let us see the causes. Here it is important to note that majority of the accidents took place in consumer premises and to the common public. See here, consumer premises 112, and to the public it is 182. Out of this, snapping of conductor and due to the use of metal rod and ladders near electric lines are in the high end. See here, rod using iron rod and ladder, then the snapping of conductor. These are in the higher end. Now, I am showing you some accidents, paper cuttings. We should get an idea about electrical accidents. Here, this person was repairing a washing machine, and here he was, this fellow was clearing the plants near earth pitch. Accidentally, he got shocked through the broken earth wire, which can carry a return current that caused his death. Similarly, in this case, due to the temporary non-standard wiring while the boy was handling the small electric motor of the aquarium, he got electrocuted. It was happened during a construction of his house. Okay. Now let us see another this accidents, and here are some other recent accidents. Here, this guy was climbing a coconut tree, but part of the tree was touching the nearby electric line. And here in this case, he was also repairing a washing machine. See here, actually it is not a recent one. This lady got electrocuted from the earth wire, which was broken when she was clearing his front side of her home. Then In this case, she was handling the charger of a torch, which caused electric shock. Actually, it was not the original charger of the torch. And in this case, the 3-year-old child was getting electric shock while he was trying to put on the TV. From the plug, he got electric shock, and during that time, it was raining and lightning. Now, I am showing you some examples of electrical accidents. Actually, I listed these things from my own experience. Just I will explain here and there, not in detail, examples of electrical accidents in residential premises. From earth wire, I have shown you some examples. Then while operating and repairing these electrical appliances, iron box, mixie, TV, etc. Then while plucking jackfruit, coconut or mango using metal or iron rod and near electric lines. See, I am showing the examples of electrical accidents happened to our residence area or near to our house or inside house. Okay. While working through metal ladder means it will not be insulated. See, I like to give an example. I faced an inquiry regarding this item. See, house was painting, and the painter was painting a portion of the building which was below the EST line. You know, EST line means it is not necessary to touch the line to get electric shock. By induction, it will be getting electric shock, and the painter died due to this EST line. An EST line coming in contact with that ladder. Then snapped electric lines, then temporary wiring during construction of houses, then from damaged service wires. Damaged service wires, because I like to give you an example. There was an accident in Changanasheri, Kottayam, for which I was conducting the inquiry. There was a joint or a strand coming out from the service wire, and it was touching the support wire, or we call it as guy wire of the service wire. This guy wire was connected to a truss work, GI truss work of that house, and a girl belonging to that house got electrocuted touching that truss work. Then through metal made clothesline, or we call it as sada. In Malayalam we call it as sada. See, this clothesline will be one end of the clothesline will be connected to electric post, or it may be actually it is a metal made, and it may be touching some temporary wiring or joint live wire. It may be. See, I faced 2-3 incidents belong to this category. Then when changing electric bulb. Actually, when you are changing the electric bulb, you should off the supply. Then children playing near electric lines or flying kites near electric lines, pattam. Then when doing priming of water, I think 3 years back, there was such an accident happened in Kottayam during priming of water pump. Then while operating faulty main switch, actually there is an ebonite rod, it should be an insulator, but due to the aging, it got complained and it was conducting electricity, and while operating the main switch, he got the electric water. Okay. Now let us see what is electricity. To study electric safety, we should study what is electricity and some basic terms. We heard about various types of electrical accidents happen. For us to be safe and to understand about safety handling of electricity, we need to understand some basics about electricity, such as what is really electricity and how it is felt and how it is measured, etc. See here, water stored in this tank, and it will be flowing downward when we open the tap, and means water moved from one place to another place. So in physics we call a work is happened here due to the change of displacement of water. So the water stored in this tank was having a potential energy When we opened this tap, it was coming down by conversion of the potential energy to kinetic energy. Here I like to tell you a word, potential. Water stored in a height will have potential energy. This potential caused the movement of water. A similar word is there for electricity also, which is called the same word, potential, or we call it as voltage. This voltage or potential, we can say it as the cause of electric current. If there is a voltage or accumulation of electric charge, see, I am replacing water with electric charge. So accumulation of electric charge means there is an voltage, and this voltage, this higher voltage will cause a flow of current. Okay. Now, when we create a path for the electric charge to flow, a current will be happened and this bulb will be flowing. Here you must understand a point that water is flowing from higher point to a lower point, or from a higher potential to a lower potential. Likewise, current will be flowing from a higher potential point to a lower potential, or simply current flows from high voltage point to a low voltage point, means current will be flowing from high potential to low potential. Okay. Now we should understand some basic terms to go further. To understand the fundamentals of electrical safety, it's good to have an idea about this measuring units and etc. We know electricity, voltage, it is measured in volts. Then potential difference means potential between 2 points. Then current, it is measured in ampere, and for smaller values it will be measured in milliampere. Then DC current, AC current, resistance, then positive terminal or negative terminal, then phase or neutral, then one more point earth. We will be studying these points one by one. The opposition created for the flow of either water or electric charge is called resistance, and it is, if it is electrical, we measure it in ohms. For a battery, from a battery we are getting DC current or direct current, but for higher capacity loads, DC is not adequate, for which we use AC alternating current, which is generated in Moolametham or Muliar or so. For AC current, the direction of flow will be changing in either directions. This change of directions will be 50 times per second, which we call as frequency. So frequency of our AC supply is 50 Hertz. Just I was giving some basics about before entering our safety points. Now, the different stages of journey of electricity are generation, transmission, distribution, utilization, and protection. Today, our topic comes under utilization and protection. For example, we generate electricity in Moolametham. It is actually generated in 11 kV, and then it will be stepped up using, you can see a substation here. It will be stepped up there itself. Then it will be transmitted to transmission towers or high towers. We can see such towers nearby our home. Then at substation, see here it is a substation. The supply will be collected, and then again it may be transmitted to some other substations, or from here it can be distributed. See here to the distribution part. See here it is a distribution transformer. We are getting supply to our houses from such distribution transformers. All of you must have seen such transformers near our houses. In a later slide, we will study little more about the distribution transformer. Then here the whole power system is shown. You can see a distribution transformer here, from where we are getting supply to our house. Then in case of apartment, they will be having their own transformer. See here, generator, the current is generated in 11 kV, then it is transmitted and reaching the distribution transformer. Here is the distribution line shown to get you a clear picture. Here 11 kV line, then LT line, it is service line. Using this service line, we are getting the supply from KCB line. Here single phase and three phase meters are shown here. If your connection is single phase, there will be 2 wires, phase and neutral, and if it is three phase, there will be 4 wires, 3 phases and neutral. And in case see here, it is a sample house wiring shown. Here bulbs, then a fan, switches are shown here. Please note this socket, power socket. Here, as per standard, phase connection should be in the right side and neutral in the left side and earth connection in the top. If you closely look these circles, you can see one thing, one important point, that the earth terminal is having a little higher diameter. It is bigger in size, is it? Now, I shall show another picture. Here it is shown more details. The point to note is that the earth pin, see here, the earth pin is bigger in diameter and a little lengthy. So when we put this pin into a socket, this earth pin will be coming into contact first before the supplies get connected. So I am telling that earth is having that much importance. Another point to note here is that there must be a control switch from where supply is fed to the socket. These are the sample DBs, distribution boards installed inside our house from where all the circuits are distributed. These are MCBs, and you can see one RCD or RCCB here. This is also another DB. Now earthing. Here the earth electrodes are shown. Actually, the earth electrodes are to be strictly done as per IS Indian Standard 3043/2018. In some of the non-standard cases, simply a GI pipe will be inserted into earth, which can cause accidents and which will be affecting our electrical safety. Okay. Now, you might have seen such a lightning protections in the top of buildings. The protection can safeguard, this protection can safeguard the building during lightning. Lightning current is in the order of kiloampere, not milliampere. Such a high current can damage the building. But through these lightning protections conductors, such higher currents can be bypassed to earth. Thus, the building will be under protection, which means earth is having or earth can carry such a high fault current. So we can utilize this earth for our power system also. Now let us see how we can use an earthed iron box and how it is we are getting protection. And here you can see phase and neutral and earth. Here phase and neutral and earth will be inside the filament. And now see here, through our 3-pin plug, the body of this iron box will be earthed through the 3rd earth pin. While we are using iron box, there can be chances of leakage to the body of this iron box. The body of the iron box can be live while we are using it, but it being earthed through the 3rd pin, when we connect it, the leakage protection such as ELCB or RCCB can happen to be triggered. Suppose if we are not having such a protection device, we can get protection up to a limit, since the earthing and human body paths are in parallel, and thus the fault current that may pass through the human body will be lesser in quantity. See here, this human body path and this earth path will be in parallel, and if there is a fault current, we are getting lesser chance to get electrocutor because current is passing through this earth. So up to a limit we will be getting protection. But remember, always RCCB along with earthing will give 100% protection in such a case. I will explain the function of RCCB in a later slide. Now, for an equipment to work, we must apply a voltage across its terminals. So minimum of 2 terminals or wires will be there. If it is DC, DC supply, the terminals will be positive and negative, and if it is AC, phase and neutral will be there. The phase wire is also called as live wire. The word live is having a meaning, which we shall explain in the next pages. In some of the three-phase equipments, instead of this neutral, the neutral will not be given. Some of the three-phase equipments, neutral will not be given. 3 phases only will be given. Neutral will not be given. We can see why neutral is not given and etc. We can see in the future slides. Now, as I told you, it is a distribution transformer. I told you for a single phase connection, phase and neutral wires will be there. This neutral point, actually we are not getting it from either the generating station or the substation. Neutral is we are not getting from anywhere. We are creating this neutral point here in this distribution transformer itself. Let us see how and what for it is created. Here in this transformer, there will be a supply incoming point and supply outgoing point. We call it as input side and the other one output side. The input side is also called as the primary side of the transformer, and the other side is called as the secondary side of the transformer. 11 kV supply will be entering transformer through terminals 1, 2 and 3, or we call these 3 terminals or the phases as R, Y and B. At the primary of the transformer, 11 kV supply is given from the nearby substation. Usually such a transformer will be rated for 11 kV bar 433, 11 kV bar 433 watt. Means if we are giving 11 kV supply in the primary side, we will be getting 433 volt in the secondary side. So that's actually another important point is the same phases R, Y and B will be there at the primary and secondary. At the secondary side, the voltage between 2 phases will be 433. Remember, in the secondary, only 3 phases or 3 wires are there. Let us see how the 4th wire or the neutral is created. See, here the transformer winding is shown. It is opened. The primary winding will be connected in delta, and the secondary winding will be connected in star, just like Y. It is the delta connection and it is the star connection. So in the secondary side, see, it is the secondary side, it is connected in star. In the secondary side, the midpoint of these connections, or we call it as the star point, because this connection is called as star connection, and this is called the star point. And that star point will be earthed, and that earthed star point is taken outward as the 4th wire, and it is called as the neutral. And it is called as the neutral. 1 minute. Here, see here in this diagram, you can see neutral point here, neutral and neutral earthing. Okay. So actually, what is the benefit of creating this neutral and what for? If the star point is effectively earthed, the potential of the neutral will be 0 volts. So actually, we may not get electric shock in normal cases if we are touching this neutral conductor, since we are standing in earth or ground, and the touching point and the foot are in the same potential. But if you are touching the phase conductor, what will happen? We are touching the full voltage and we are standing in earth, so it is dangerous. That is why we call this phase wire as the live conductor, or it is live, means dangerous, but the neutral is not live. So here, by creating the neutral point, we are mainly getting 2 benefits. we are getting two benefits, because you see here we are getting single phase supply. We can get single phase connection between the neutral and one of the three phases. Thereby we can operate our single phase loads. Means we can get a 250 volt or 230 volt. Additionally, so that's one of the benefits of earthing this neutral. Additionally, by this neutral, we can get earth fault or leakage protections. We can understand this one through the operation of RCCB in a later stage. See, in this diagram, we are operating an iron box through an RCCB. RCCB function like RCCB means a residual current circuit breaker, or we call it as earth leakage circuit breaker. Actually, there is a difference between RCCB and ELCB. I am not going deep into that topic. For this study, I am using both terms intermittently, either RCCB or ELCB. So actually, this RCCB function like a security staff of an apartment. He will be recording all the persons entered in and checking whether they have gone out or not. If there are any more persons to exit from the apartment, this security is the responsible person. Similarly, here in this diagram, it will be checking the inward current. See, it is the phase conductor and it is the neutral conductor. So it will be checking the inward current and outward current. Phase and neutrals are wired through this RCCB. You can see here. There is an internal coil inside this RCCB which will be checking constantly whether this inward current and outward current are equal. Say 1 ampere current is going into the phase wire and returning to the source through the neutral wire. 1 ampere going in and 1 ampere coming out. If both of the currents are equal, the circuit operation will be stable, means the circuit will be constantly working. Consider, due to a fault of this iron box, due to a fault in the iron box, a fault current pass from its body to a human body. You can see here, means due to a fault in this iron box, a fault current is passing through human body. Consider, due to this there is a limit after. See here, actually this person can withstand only up to 30 milliampere current, because in a human body, heart is the most sensitive part. We will study it later. So here we should get the protection for 30 milliampere, or I can say this RCCB is rated for 30 milliampere. When there is a difference of 30 milliampere current in between this phase and neutral, the RCCB will get tripped and the person will be safe. Here you please note that the fault current passing through the person is returning to the source. See here, it is returning to the source or the transformer through earth to the earth neutral. So for proper functioning of RCCB, effective neutral earthing is a must. Also, please note that if this neutral point is loosely connected, instead of the zero potential in neutral, you will be getting a voltage. It may have some voltage. In our house connection, usually we can check it by measuring the voltage in between this neutral and earth. Usually it will be in between, it can be from 2 volt or 5 volt, or even 1 volt it can be there. If it is beyond this limit, complaint should be registered to KCB. It can be happened either through improper or loose contact of this neutral earthing, and or even our earthing of our house is not proper. It can be happened. So these things are, there are various reasons for this neutral earth voltage. And another thing, you must note that if this neutral is loose, your equipments will be getting higher voltage. That is also another disadvantage. If there is higher voltage, suppose say it is 350 or 400 volt, you must complain to a KCB, and it is because of the loose neutral earthing. See here, you can see a coil here, and this coil is checking the currents from the phase and neutral constantly. If there is a difference, this coil will be sensing it, and the circuit will be tripped. My voice is clear? Hello?
Very clear, very clear, very clear.
1 minute, 1 minute. See, here you can see a bird sitting without shock while it was sitting in a line alone. But when it moved its body, it is touching both of the lines, and which can cause electric shock. Means if there is a potential difference between two parts of the body, it will be getting electrocuted, or a current will be flowing through that bird's body. So I am giving the word potential difference. Due to potential difference, a current can be flowing through the, suppose even if it is human or if it is bird, the if a potential difference is created between two parts of the body, current will be flowing. Here I am showing you a human body. Actually, our human body is very dangerous when we discuss about electrical safety. The human body is composed largely of water. About 70% is water and has very low resistance. Near to skin, it is salty in nature, which can pass electricity very easily. For a normal person, the resistance in between two hands or 2 feet is 1500 ohms. But if it is wet or moist, the body resistance could be as low as 300 ohms. And if there is some break in the skin, that will be creating a zero resistance, and high current will be passing to skin. So that is what is skin. Now let us think about heart of the body. Actually, in most of the fatal accidents, in 99% cases, current will be passing through the heart of the body, and then only it is becoming fatal. What is heart? Actually, heart means it is a blood pump. It is working just like a water pump. It is working constantly from an electricity or small electricity generated from our body itself. So it is a blood pump working from the electricity generated in our body. So when another supply or electric current is passing through that heart, what will happen? It will be, or its rhythm will be destroyed. Or actually, in medical term, it is ventricular fibrillation. It's that operation will be mostly spoiled. So here I have shown some data to understand about this ventricular fibrillation, etc. 100 joule is enough to start a heart or to stop a heart. Means it that 100 joule is enough to start a stopped heart also. Then about 1000 joule can blow our entire body. Then about this, we will study some step potential and touch potential later, and these are the 50 volt. I will explain later that it is the threshold voltage that can create damage to our body. Then about 10 ampere regarding regardless of voltage. Means another question I want to ask you is which is dangerous, of whether it is voltage or current, which is creating accident. We shall explain later that. So 10 ampere current, regardless of voltage, no, voltage is not a matter, should be treated as hazard. In normal conditions, 30 milliampere current is the threshold value to create ventricular fibrillation. I explained ventricular fibrillation. Now, see here, how we can get electric shock. See here, it is actually a technical point. You please listen carefully. How we can get the electric shock? It can be happened either through a touch potential, or step potential. There are two words. Potential, you know. There is touch potential and step potential. Please, this picture here, this tower got a faulty or induced voltage through some insulator failure or something like that. Means its surface is having voltage. Then if a person standing here touches the tower, there will be a passage of current through his body. This effect is happened since he touched the tower, and that is what is called touch potential. Means when he touched the tower, a touch potential was developed, and because of that touch potential, a current was flowing through his body, and electrocution is happening. Now, in the second case, he is not at all touching the tower. He is walking near the tower. Then in between his feet, see, in between his feet, a potential difference is developed due to the potential gradient from the tower. Means this tower is the energized object. Due to this voltage in the tower, there will be a potential gradient through this ground. And when he is walking through that ground, a potential difference will be developed in between his feet, which cause electrical accident, or it is called this one, step potential. See here, you can see some simple definitions for touch potential and step potential. Touch potential is the voltage difference between the energized object and the hand or feet or part of the body. Means he can touch either with his hand, feet, or any part of the body of a person in contact with the object. The electrical current flowing through the object enters your body through the part touching the object and leaves through your feet, causing damage to your internal organs. So here, touch potential was the cause of the accident. Then about step potential. Step potential is the voltage difference between the feet of a person near an energized object or grounded object. See here, this step potential and the touch potential, it's a threshold values. Means the value which can create accident is the entry point is 50 volt or on AC or 120 volt DC. Means if the step potential or touch potential is more than 50 volt, it can create accident. Okay. Now, here the definition I took from IS 3043 2018. And it is actually a little more explanatory. The meaning is nothing but touch potential happened through touch, but step potential happened through a potential difference created in a surface through the potential gradient from an energized object. I will explain potential gradient later. In case of step potential, the two parts of the body may not necessarily the foot itself. Usually during lightning, a ground potential rise will be created through earth surface. Ground potential rise, it will be created during lightning. So usually, so during that time, if a person walking may get electrocuted through step potential, means of potential in between his feet. That is why during lightning, cattle get electrocuted more in number since their leg distance is more. That is about the step potential during lightning. Now here you can see here pictures here. See here in the current is passing through two hands, so heart will be coming in circuit and it will be dangerous. In the second case, it is step potential, means a potential in between two steps, and here some organs like a kidney will be there that will be affected. And here in out of these two cases, the second case D is more dangerous since heart is a part of that circuit. Okay, now here I am trying to explain the potential gradient created from a downed conductor. If the line voltage is 11 kV, the conductor will be the center point. Just like ripples of a voltage bands means here it is the band. Voltage ripples will be created around the fallen conductor. Say here it is 11 kV, here it is 10 kV, 9 kV, 8 kV, etc. If someone walk through this ground in between his feet, there will be a potential difference, and he can get electrical current. Why I am explaining these things for home safety? Because actually these all down conductor or snapped conductor all belong to home safety itself, because we will during a rain we will be going out, we should be very careful about this thing. Okay, that is about the potential gradient. Now, how to prevent electrical accidents in domestic premises? Effective earthing as per IS 3043 is a must. Earthing and it should be done in the proper way, and it should not be a namesake one. Then each of the circuits should be provided with overload protection such as fuse or MCB of adequate rating. Then RCCB or ELCB of high sensitivity, example 30 mA should be incorporated. Then the 3-pin plug should be of 3-pin with finger grips. Then actually 3-pin plug will be using for an equipment with a metal body. And if it is not having a metal body, 2-pin is necessary. That is written here. 2-pin plug should only be used for plastic molder or plastic clad device. That means there is no need of metal connected to earth. Now the flexible cord should not be twisted cable, but IS marked 3-core PVC sheathed cable. The termination should often be visually observed. The terminations should be visibly observed, and if found charred, if found damaged, should be trimmed and reconnected. Then never an appliance be handled with wet hands or wet floor. The floor in the kitchen should be dry. Okay, as I explained in the when a fault occurs, the see here as I've explained about the fault. See here 1 minute. Okay, when a fault occurs, the protecting device RCCB, fuse or MCB must operate, and our circuit or our house itself should be protected. 1 minute. Sorry for the trouble. Okay, then during a fault, either RCCB or fuse or MCB should operate, and our equipments or our circuit, everything should be protected. Now, actually, what is RCCB? It is checking the difference between the incoming current and outgoing current. I explained to you. Consider the winding of our motor, our water pump. Suppose it is shorted. What will happen? The winding of our water motor is got shorter. What will happen? The phase and neutral will be coming in contact, or it will be shortened, and it will create a high current. High current means not like a small leakage current or milliampere range. Say it can be either 5 ampere or 10 ampere. It can cause damage to our house. Immediately, our protection should work. Actually, for this high current, which is the device to act, whether this RCCB will operate, the purpose of RCCB is different. The RCCB cannot give protection to such overcurrents. RCCB is for earth leakage protection, but fuse or MCB can give protection to overcurrent protection. For this 10 ampere or 5 ampere, we can get protection through fuse or MCB. We can get, see here fuse is shown and here it is MCB. Now we can get, so this MCB is for overcurrent protection and RCCB is for leakage protection. But actually we can get a combination of RCCB and MCB. See here it is RCCB and MCB. RCCB is for leakage protection and MCB is for overcurrent protection. We can get such a combination which is called RCBO. So we can get the protections, leakage protection and overload protection with the RCBO. Another important point. Actually, you may surprise why I am explaining this breaker and isolator to home safety, but you must know. Please see these two devices. One of them is a circuit breaker. Here it is a circuit breaker, and the other one is isolator. Both are looking somewhat similar. Actually, both are for different purposes. Never replace a breaker with an isolator. The isolator is having lesser price than a breaker. I shall explain where an isolator is required. Consider we have an agricultural pump, means it will be in a remote place from our main switch. We want to repair the pump. Making of the main switch, will it be enough to repair? Will it be safe? We are making of the main switch and we send the technician to operate that or repair that agriculture pump. Will it be safe? Will it be safe? See, the main switch is in an unseen place for the operator who repair the pump. No guarantee that someone make it on while he is repairing it. In such occasions, we need an isolator to be placed near to the water pump. Here the isolator is only for supply isolation purpose. It will not give protection like a fuse or MCB. It will not give protection. Here the isolator is only for the isolation purpose. Then it is just like our normal switch, you know, our normal switch in our house connections. This isolator is just like a normal switch. If a 10 ampere current pass through a 5 ampere switch, what will happen? It will be burned, is it? Likewise, this isolator also will be burned. So never allow to replace a circuit breaker with an isolator. It won't give, this isolator will not give protection. The purpose of isolator is entirely different. I am telling you because some of the technicians may be replacing this MCB with an isolator, and you being non-technical, you may not understand the difference in between them. That is why I am explaining this one. Now, how to treat victims of electrical shock? There are many incidents happened in our state that in the same electrical accident, 2 or 3 persons died. For example, about 1 year back in Vidinyam, Thiruvananthapuram, 2 persons, father and son, were faced the tragedy. You can see the newspaper cutting in the screen now. Father was trying for tender coconut from his coconut tree, but accidentally the iron rod he used cross-linked with the nearby 11 kV line. He got shocked and fallen, but still his body was in contact with that 11 kV line through the iron rod. Then his son, coming by bike, noted smoke in terrace. Immediately he rushed and seeing his father means his blood related person, seeing his father, tried to escape him, but he was also becoming a victim. So please note the following procedure to treat the victims of electrical shock. Means this procedure should be noted to treat victims who faced electric shock. First of all, you should make the supply off. For making it off, you can call the nearby KCB office, or if you are having a technically sound expert friend, you can inform him to immediately shut off the supply. And if there is no chance, actually the supply conductor or something, for example, in this case, through that iron rod supply is touching that human body. So we have to isolate the supply and we can't remove that iron rod. So if it is not possible to remove, or if it is not possible to off the supply, we should relieve that person from that supply conductor or something touching that body. Try to free the victim from the live conductor by using dry piece of wood, dry plastic or wooden broom, or dry leather clothing or other non-conducting material. Do not make direct contact with any part of the victim's body, with any part of your body. If you do so, you will be becoming another victim. Then, after relieving him from the electricity part, check whether he is having breathing. If he is having breathing, immediately call a doctor or admit him to the nearby hospital. If he is not having breathing, immediately we should give CPR, artificial respiration we should give. And there is a long procedure of this CPR, and we need to give CPR. And along with that CPR, we should loosen the clothing about the victim's neck, chest, and abdomen, so that breathing is easier. Once the victim is breathing, protect him or her from exposure to cold with a warm cover if possible. Then keep the victim from moving, because the total body is damaged. After a strong shock, the heart is very weak. Any sudden effort or activity may result in heart failure. Send for a doctor and stay with the victim until medical help was arrived. So it is the actual procedure. We must follow it very strictly. Okay. Now I have some other portion to discuss, but I like to give explanation about the safety procedure, and we should. I will try to explain one by one in the possible cases. See, safety precautions, general safety precautions. Inspect. See, almost all the precautions are belonging to home safety. So you please know. Inspect power cords regularly and replace when needed. Then always use RCCB or ELCB around areas where there is water, bathrooms, kitchens, deep sinks, or outside. See, RCCB must be there at the entry point. And if you are having some dangerous spot inside our house, you can provide another RCCB also, no issue. And wear rubber soled shoes and safety gloves when operating power tools. Replace if uses or working where there is a possibility of electric shock. Means to replace the fuse also, you please use soled shoes and safety gloves, because it is dangerous. That's why. Then use double insulated tools. Then utilize non-conductive tools or ladders. Use rubber floor matting when available. Clean and inspect tools when job is finished. Then when working outside, look up to be sure you will not come in contact with the power lines. Then make sure kids fly their kites in open fields, not below that EST lines. Then make sure kids do not build their tree houses near power lines. Then never use electric appliances or tools around water. Then do not use power tools with defective or broken insulation. Then always disconnect the power source before repairing electrical equipment. Then never touch electrical outlets with your fingers or objects. Never touch electrical outlets. It will be live. So never play with the electrical cords, wires, or switches, and keep them away from the heat and water. If you are in contact with the water, never touch anything electrical like a light switch or hair dryer. Never play around electrical wires or equipment, and stay away from areas marked danger or high voltage. If climbing trees, stay away from those near power lines. There are many incidents happen. The owner itself will be cutting the tree touchings from that touching the power lines, but he is actually not permitted to do that one. Then never throw objects at wires or utility poles. Stay out of open areas and away from trees during electrical storm, or go indoors. During lightning, please go indoors. Then stay in the car during storm, because the rubber tires stop electricity from passing through it if the car is struck by lightning or fallen cable. Actually, I am having some other portion to explain regarding this. I will, if I am getting a time, I will explain this one in detail. Then turn off lamps when changing light bulbs. I already told. Do not put your fingers in a light bulb holder. Tell someone if you see a frayed electrical cord, a damaged electrical cord. Suppose it can be even KSB line. It may be touching a tree, and it is almost half of the strands of the service of the electric line is cut. You are thinking that, oh, it is not my part to report. You must report, because tomorrow it may be cutting down, and your relative or you yourself may be getting electrocuted. Okay, now keep combustible materials away from lamps or heating devices. Then disconnect appliances before cleaning. Be sure all electrical equipment for swimming pool is grounded properly. Then call the fire station in case of an electrical fire. If safe to do so, unplug the appliance and use DCP. See, during a fire, you should not use water to clear the fire. It is very dangerous. The water itself will conduct electricity, and you will be becoming a victim. So firstly, you unplug the appliance. You unplug the appliance and use DCP, dry chemical powder, and or you can use carbon dioxide extinguisher. Actually, DCP is better because of the reason explained here, because carbon dioxide will cause a reignition. Then call the concerned KICB office if you see a person who has been or being electrocuted. If you are seeing a person, you please immediately call KSB also to put off the supply. Then don't swim during an electric storm. Don't plug in electrical appliances in the bathroom unless specific safety device has been installed. Then never remove the grounding wire in a three-pronged cord, 3-pin plug. Never remove that third conductor, ground conductor. Then do not assume you have unplugged an electrical device. Do not assume. Check it and make sure. Then do not leave electric devices where small children may have access. Then never climb utility poles, transmission towers, or fences around substations. Now about electrical cords, electric wires. Any exposed strand of a wire could cause a shock or burn. I already explained on an incident. Then before you work on a rooftop television antenna, be sure the area is clear of power lines. Install antennas where they won't touch or fall on electrical lines. Always keep cords away from cutting blades of saws. Inspect power cords regularly and replace when needed. Then replace. Don't attempt to fix cords that have been cut or damaged. Never pull out a plug by the cord. If a cord or plug is warm or hot to touch, unplug it immediately. Check wires, extension cords, and appliances for signs of wearing. Never bend or remove the ground thread wire. It is designed to help prevent shock and may save your life. Then don't use extension cords as permanent wiring. Actually, if you are using permanent wiring, means your wiring is not standard. Then unplug and put away extension cords that are not being used. This will reduce the risk of children chewing on it and playing on it. Then do not overload an extension cord. Recognize the signs of overheating, distortion, and discoloration, and unplug the cord. Avoid overloading by first checking the cord's electrical capacity. Then never puncture insulation of electrical cords by nailing them to any surface. Okay, I think those things are very clear to you, and it was not able to explain one by one. Now let us move to different types of electrical accidents. Mainly there are three types of accidents when we study home safety. The severity of an electrical shock will be determined by what quantity of current is passed and how long it is passed, through which part of the body it is passed, and what is the nature of the current, whether it is DC or AC. Means the fatality of electrical shock depends upon the amount of current or amount of body resistance, then path of the current or path of the body through which part the current was flowing and how long it was flowed, then what about the nature of the current. Okay, now here I quoted a portion from the Indian Standard IS 3043 2018. Here you can see current of 1 milliampere passing through our body will be giving a slight tinkling sensation. It will be slightly feeling that current is flowing. 1 milliampere current. Then currents from 1 milliampere to 60 ampere will be termed as let go currents. Means it will be going with unpleasant sustain, generally do not impair the ability of a person holding an energized object to control his muscles and release it. Then actually when current or when we are getting electric shock, there is a tendency to withdraw ours. Unknowingly we will be withdrawing our hand. Then if the current is from 9 milliampere to 25 milliampere, currents may be painful and can make it difficult or impossible to release. Means it will be difficult to release. Then about for still higher currents, muscular contractions could make breathing difficult. These effects are not permanent and disappear when the current is interrupted unless the contraction is very severe and breathing is stopped or minutes rather than seconds. Then if the current is from 60 milliampere to 100 milliampere, it will lead to ventricular fibrillation. I think I told you about ventricular fibrillation. It is disturbing the rhythm of heart. So that is called a ventricular fibrillation. There is a defibrillator in some of the industries. Defibrillator will be there. It is a rule to keep it there, and it can defibrillate, means it can be reversed. This process can be reversed. Here I took this graph from IEC 60479. It is explained about current passing through human body. Here I took the x-axis, the current passing through human body, and this current is passing through persons for a current path corresponding to left hand to right, to left hand to feet. Means left hand means to feet means heart will be coming there. So such a current is taken the x-axis, and the time or the duration of the current is taken in the y-axis. Here you can see the region AC1, AC2, AC3, AC4, etc. And here AC4 is very dangerous and it is making ventricular fibrillation. And AC1 it will not be sensible. Anyway, I am not giving deep into this graph, just to show you a current exceeding 30 milliampere. See here 30 milliampere. A current exceeding 30 milliampere is likely to be fatal unless it is interrupted in a very short time. 30 milliampere means we are using RCCP for this protection. If 30 milliampere is there, that must be cut. The supply should be cut within a predetermined time. Before the person get electrocuted, it should be off. That is the purpose of RCCB. Now here I am explaining about the path through which part the current was flowing. Actually, I have shown this picture earlier. If the heart is there in the path of, or is there in the circuit, that will be more fatal, creating danger. And then about the duration of the current passing through human body. Then see here, I am showing that 500 milliampere current will not make any ill effects, will not create any problem if its duration is less than 20 milliseconds. And see here, these currents are making fibrillation. See, 21 milliampere for 30 seconds. It will be making it will be causing fibrillation. And if it is 44 7 seconds, that also will create then 67 milliamperes for 3 seconds. So the duration of the current passing through the body is having a vital role in electrical safety. Now about this nature of the supply, about the frequency of the fault current, whether AC or DC, which is more dangerous, whether DC is dangerous or comparatively which is more dangerous. Actually, we can't say which is more dangerous. It depends upon the situations. DC current can create more heat than AC, and here in this aspect, DC is more dangerous. Then about AC. AC means alternating current. It is varying and it is changing directions. So about AC, it is having the nature of alternately reversing its direction. A direction will be reversed. Such brief moments means it is passing through zero. So such brief moments can give the afflicted muscles to relax, and between the alternations. So in between that moment, your muscles will be getting relaxed. So in this aspect, DC is more dangerous than AC. So because DC will not have such a zero crossing point. About the frequency, see 9 Hertz to 12 Hertz, it is more dangerous because it will be creating a fibrillation. If the frequency is high, in the range of megahertz, it will not be much problematic because of skin effect. That's a technical word, skin effect. Means the current will be tending to pass through the skin of the wire or skin of the body. Okay, when the current is of high frequency, but if the frequency is further more again, that impedance will be going down, the value of the current will be again high. Okay. Then about electric burn. Electric burns are not the same as those due to fire. Actually, from a fire we will be getting some burns. Electric burns are not like that one. It is what we call it, the current is passing through body, and we may say it is cooked, or it is totally damaged, it is burned. They are due to the heating effect of electric current passing through the body issue, and thus are usually associated with the electric shock, often occur in or on the skin at the point of contact with the electric system. Electric burns are usually very painful and slow to heal, and often will result in permanent scarring. I want to tell you an example about electric burn. When I was working in a Kasaragod as electrical inspector, there was an accident that happened to a sub-engineer who was originally from Tripura. After the accident, I visited him for taking his statement, because we are the inquiry people and we have to submit the report to the government. So I went there to meet him, and it was to get his statement, and found that his right hand was burned and replaced with an artificial one. See, left hand is not having an issue. Then I surprised to see that he was escaped because of the 11 kV conductor was fallen through his right hand side during the work, and thereby his left side or the heart was safe. It was really God's own decision to give him further life. Now, about this third one, electrical accident, fire. We know many fires happened even in India, even in Kerala. And India, in the northern side, there are many fires occurring. And there are many reasons for fire. These are the reasons: overheating of conductors and cables due to overloading, and current leaking to earth or between conductors due to low levels of insulation resistance, then overheating of flammable materials placed too close to electrical equipments, ignition of flammable materials as a result of arcing or the scattering. Means if you suppose we are having a water motor pump, you may be keeping some paper or something flammable materials around that water pump. Not be done, because heat will be developed from the motor. See here, I have shown on fire angle. For getting fire, oxygen, heat, and fuel is necessary. Heat will be getting from electricity, or heat will be getting from the water pump. Fuel means you have provided some flammable materials there. Then oxygen, we will get it from atmosphere. So fire will be occurred there. If you are facing a fire, I already told you to use DCP or carbon dioxide fire extinguisher. Now we are moving to the end of our topic, and there are some case studies I have to explain. Out of this, I like to explain on important one, incorporating step potential and touch potential. I explained earlier, touch potential is very important with the home electrical safety studies. But when chances of potential gradient is there, step potential is also important. Suppose we are traveling in a car, and 11 kV line is fallen over our car. How we can escape? As we know, the tires are made of rubber. For a reasonable period of time, no issue sitting inside. But by the time we need to inform the fire station and KICB or the respective utility. If we sit inside for long, the leakage current through the tires can create smoke or fire. So better come out and escape as early as possible. But how? The vehicle body is being touched with 11 kV conductor. We are also will be in the same potential, 11 kV. We are also will be in the same potential. So coming out is not so simple. We need to jump out such that whole body should be separated from the vehicle body simultaneously. Otherwise, we will be getting some touch potential. Means one part of the body will be touching the vehicle and the other part will be our foot will be touching ground. So we will be getting touch potential. Then we escaped, we came out. Then what to do? Once we are out, we should walk carefully. Why? The downed conductor. The downed conductor is there, and this will create potential gradient. And when we walk, there will be step potential. So you join your feet and jump forward, and keeping a distance, you will be escaped. Okay, now another case study I want to explain is here. A few children were playing on the open terrace. Few children were playing in the terrace. They all dispersed after the play, after their game. They dispersed after that. One child was missing, and it was lying dead on the terrace. You know why? He was urinating to the nearby electric line. So we should be very careful if our children are playing near electric lines. Okay, I think home safety, it is reached your limit, reached your expectation, And it was actually it was a detailed topic. I was planned to explain how the touch potential and step potential are developed, and how to handle electrical equipments. And I told you about this heart, and heart is in the left side. So you never handle your equipments with wet hand, and if possible you put it with right hand when we are putting that plug top in the socket. You please use right hand itself, because your heart, it is very dangerous, and if your hand is wet, it is more dangerous. So I think the topic was helpful to you. I'm closing with this section. Okay, Sunanda Uma.
Thank you very much, sir. Very excellent presentation, very detailed. So thank you very much on behalf of HSC Forum. The floor is now open. Participants are requested that if you have any questions, kindly post in the chat box, or you can unmute and also post directly also. You can unmute your mic and then introduce yourself and then post your question. There is a comment from Mr. Ashish Kumar. Thank you very much, sir. Session was really very informative and an eye-opener.
Thank you.
Definitely, I would agree with you.
I think the step potential and touch potential is clear to you. And
yes, very much.
You please
very
note
much.
that step potential means may not be step itself. Even it can be two portions of our body unknowingly. From the floor, there will be a potential difference when we are laying or something like that. May not be step itself.
Anybody else want to ask any doubt? I have just, since others contemplate, I have just one question. In your slide, you are comparing AC versus DC, which is more dangerous. You showed that in AC, 9 to 14, around 9 to 14 hertz is the most dangerous. Does it mean that a variable frequency drive, when you are running at a low RPM, the chances of a shock are more dangerous than when it is running in full load condition?
See, actually, it is a medical subject, and whether DC or AC is dangerous, it is actually under research. See, our heart is working in low frequency, is it? So low, I understand that low frequency current is making more defective, and high frequency, it will not affect your heart rhythm. That's why I told like that.
I know I didn't compare AC DC. I was only looking at the AC itself. An AC current, which is of 50 hertz, which is not normally we get at homes, is less dangerous than an AC current of 9 hertz or 10 hertz, which normally happens when you are using a variable frequency drive. So you need to be very careful when taking troubleshooting in a variable frequency drive equipment or something.
Yeah, it must be. It must be very. You will be getting low frequency there.
Yeah.
Yes.
Yeah. Another comment from Mr. K.R. Radhakrishnan, DGM Manufacturing Maniyar. Excellent presentation, well presented. The basics, thank you very much. So I think well appreciated. Since there are no questions, we will move to the formal vote of thanks. Thank you, Mr. Jameskutty Thomas. You started off the presentation talking about some real accidents that has happened in real life domain, showing the newspaper cuttings, how the common man is exposed to the dangers of electricity, which we take very much for granted. Nevertheless, they can be very dangerous, and then many unsafe practices and hazards that can lead to such electrical accidents. Then followed by a simple analogy, which I loved to. I loved that two slides of how the water flows from higher potential to lower potential, comparing a potential difference of water to electricity's potential and how the current flows. simple way of explaining fundamentals of power electricity. They followed by the importance of earthing, the lightning protection and the iron box, how it's just is to be used and protected. Then the second novelty was the concepts of touch potential and step potential for the common person not exposed to power or not an electrical engineer. They explain in a very lucid and simple manner. And hazards caused by a snapped conductor and how the touch potential and step potential play a role and the impact of it. You also talked about how accidents can be prevented in domestic premises, more specifically, importance of earthing as per IS standards 3043/2018, the overcurrent protection requirements using MCB, the need to use RCCB or ELCB, uh, how a 3-pin plug is very important, why the kitchen floor has to be dry, and also proper use of flexible cable without twisting it or without damaging it. Then you also explain the fundamental differences between RCCB and MCCB and the benefit of using a combined one as RCBO, which combines the overcurrent protection, also a leakage protection, thereby protecting the human beings as well as the equipment. Then the difference between a normal isolator and a breaker for all these things were definitely very, very useful. And in spite of that, should a shock happens, you give a explanation how to treat a shock victim and the several slides. I think there were 3 to 4 slides of don'ts rather than do's, covering the safety precautions. Tells us very, very clearly that there are so many things to be taken care of to ensure electrical safety. And it's very important for all of us to be aware of such requirements and practices to be in place to ensure that not only our family members, the society remains very safe. And then I think you also touched upon to the fact and the types of electrical accidents, which is basically the shock, which everyone knows, the burn injury, which is different from the normal fire injury or a fire burn, and the electrical fires, what causes it, and also the magnitude the impact of the current and the duration impact of the current with graphs and the charts you explain very nicely. So overall, very, very interesting and useful session for all of us. And the slides were also very, very beautifully prepared. I think you would have spent a lot of time making such slides. Otherwise, a common man would find it very boring. It's a very dry subject, but the slides kept us glued to the screen. So I'm definitely thankful to you for all the pains that you have taken for making this talk very, very useful for all the participants here. Thank you very much once again on behalf of HSC Forum, National Safety Council Kerala Chapter and Electrical Inspectorate for the enlightening session on enhancing electrical safety at homes. My thanks to all participants present here, and I'm definitely sure that you would all have benefited from the beautiful talk that Mr. Jameskutty tendered today. I would like to also remind the participants that tomorrow we have the last talk of the Safety Week webinar, which is primarily for electrical engineers on electrical safety, arc flash and mitigation. Definitely very important topic for practicing engineers, especially in industries. Please do join for the program tomorrow. Wishing you all a great evening. Once again, thank you all. We now formally close the session. Thank you. Thank you all.